So to motivate the discussion, I want to talk to you about two different situations. You're in a classroom, and the average of the grades in the classroom is a 50. Now, that's a bad grade. I know an average of a 50 is not good, but it's easy for us to remember because 100 is a perfect score, 0 is a worse score, 50, an average of 50 is like a terrible average, but it's right in the middle, so it's easy for us to understand. Now, there are many ways to get an average of 50. That's the thing I really want you to understand. Let's take a look at two different ways really quickly. So, average of the class is 50. This is the first scenario. And here's another set of grades that give an average of 50. All right. So let's look at a couple of different situations. Let's say that what we have is, in this situation, we have the following grades. Let me switch colors here real quick. We have 49, 49, 49, right? And 51, 51, and 51. Now notice, we have 3 grades that are 49, which is below 50 by 1 point, and we have 3 grades which are above 50 by 1 point. Now, you can do the average if you want mathematically by adding up 49 plus 49 plus 49 plus 51 plus 51 plus 51. You add that up, you're going to get an answer of 300. So if we add these guys together, the mean is going to be the sum, the addition of all of these things, which is going to be 300. And then you're going to divide by 6 because you have 1, 2, 3, 4, 5, 6 grades, and you're going to get an average of 50. So I'll put down here a mean of 50, which is exactly what we said. I told you I'm finding some situation where the mean is 50. Now let's look at a different situation with different grades. Right? Let's look at a different situation. So in this case, the grades are all clustered together very near what the average value actually is. Some a little bit lower and some a little bit higher. Let's take a look at another situation. What about a situation when you have a grade of 20, 20, 20, those are really bad grades, and then 80, 80, 80. Notice what's happening. You still have 6 grades, but these 20s are 30 points below the average, and these 80s are also 30 points, but they're above the average. So you have some lower by 30 points and some higher than 30 points. What do you think the average is going to be? Well, if you calculate the mean, you're going to add up all these numbers. What are you going to get? You actually get 300. And you'll again divide by 6 because there's 6 of them, so the mean is going to be equal to, again, 50. Notice we have 2 situations with totally different characteristics. The mean, or the average number, is 50 in both cases. So if I tell you the average grade of my class is 50, then that does tell you something. It tells you what the middle value of that data set is. But it doesn't tell you anything about the spread of the data, because I just gave you 2 situations where the average of those grades are the same, both 50. But in this case, the grades are very close to 50. And in this case, we have lots of grades lower than 50 and lots of grades higher than 50. And if you want to see that graphically, which I think is a good idea, let's do it probably in black here, then you might say something like this. We'll just draw a little diagram here, right? Where the average was a 50. So I'll put that in the middle, right? And what you have kind of in this situation is you have you have 3 grades which are lower than 50, and 3 grades which are higher than 50. So the grades are very clustered about 50. But over here, because you have the 3 at 49 and the 3 at 51, right? But over here, you have 3 grades much lower down here at 20. And you have 3 grades much higher, which is up here at 80. You see what I'm saying? When you look at these 2 situations, they both give you an average of 50. Why? Because when you make an average, it's like a balance. You have grades that are lower than the average and grades that are higher than the average, and they kind of balance, and the average is in the middle. But just like a seesaw, just like a teeter-totter at the park, you can have 2 kids on the end and it's balanced. And then if both kids scoot near the center, but they're the same equidistant from the pivot, you're still balanced. And you can move closer and closer or farther and farther, and the thing is still balanced. So we can move these grades farther away symmetrically or closer together symmetrically, but we get the same average. So it's important to know the center value, the average value, but it's just as important to know the spread, because I want to be in this person's class. Well, I should say that. I shouldn't say that. I don't want to be in this person's class. But what I'm saying is that this information of being these grades here is telling you that the teacher is instructing in such a way that almost all the kids are getting near the average of 50, right? Whereas in this situation, some kids did really, 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 really good, but some kids did really, really bad. So why would you care about that? Because maybe Maybe he's neglecting half the kids in the other situation. Maybe some of the other kids are sleeping. There could be any number of reasons why some kids would be so far off to one side. Here, you have a great amount of consistency. So in a university class, a lot of times, the average is important, but if all of the grades are clustered right around the average, then it means everyone did the similar in terms of the entire group. So it's important to know not just the average, it's important to know how clustered the data is. So this is a measure of the spread of the data. This data we say is very spread out or dispersed about the mean, and this data is very clustered or very close to the mean. All right, now let's move along to our actual problem. Now that we have that in our mind, let's move along to problem number 1, and we're going to calculate what different ways of representing how spread out this data actually is. So we have the number of wins of a baseball team, right? So we have number of wins of different baseball teams, or you could say of a baseball team on different days. So, or I should say different teams in a region. So this team won 6 games, this team won 2 games, this team won 4 games, and so on. So before we do anything, let's just see what the data looks like. This team won 6 games, another team won 2 games, this team won 4 games, another team also won 4 games, this team won 3 games, this team won 7 games, and this team won 9 games. Let me just double check that I've done that part correct. Now, where do you think the average value is going to be for this? We're going to calculate it in a minute, but the average is going to be somewhere in the middle. You have some points lower, some points higher. It's going to be pulled one way or another. It's going to be somewhere around here when we calculate the mean. And we're going to do that in a second. But now we're focused on trying to get a measure of how spread that data is. All right? So there's 2 ways to do that. The 2 ways that we're going to learn in this lesson. The first way is called finding the range of the data set. The range is simply taking the biggest value in the data set, 9, and then the smallest number in the data set, 2, and just subtracting them. Because if you have the biggest number and the smallest number in the data set and you subtract them, you obtain a measurement of the width of the data set from the extreme value on the right to the extreme value on the left. So the first thing to do is arrange these points in order from least to greatest, and we can just read it right off the table. It's a 2, followed by a 3, followed by 2 number 4s from right here, then a 6, then a 7, then a 9. Just read it right off the table. We already put it there. 2, 3, 4, 4, 6, 7, 9. Now, the range of this data set is 9 minus 2. It's just the largest point minus the smallest point. So the range of this guy is equal to 7. The range of this guy is equal to 7. All right? And we're going to write these numbers down on the chart as well in just a second. The range is equal to 7. Now, what does this tell you? If I were to calculate the mean of this data set, which I am going to do in just a second, I'll give you the mean, and then I tell you the range of the data set, then you have the idea that we're trying to get, which is the center of the data set, and the range tells you how spread out the thing is. So that's a great way of doing it. I can give you if you're talking about grades in a classroom, I can give you the mean, which is the center, and I can give you the range, which is the biggest minus the smallest. It gives you the width of the data set, and that gives you a measure of how spread out the thing is, right? So for instance, over here, the range of the data set is very large because 80 minus 20, right? And then the range of this one is very, very small because 51 minus 49. So it does give a measure of how spread out the data set is. But the problem with using the range is that what if we have outliers? Then the outliers are going to always be at the very end of the data set, and it will give you a very big value for the range, and your range calculation will only depend on the outliers. So think about house prices in a neighborhood like we talked about in the last lesson, right? If I have, let's say, 9 or 10 houses in a neighborhood that are all around $95,000, and then one mega mansion that's $20 million, that's a total outlier. Some rich person just built a compound. Then the range of the data set would be the 20 million minus whatever the smallest house price is. It's going to be millions of dollars, and it's going to lead you to believe that the prices of those houses are very, very, very wide range and very, very wide value between smallest and biggest, which is true. But the problem is the only reason the range is big is because we have only one guy, one outlier, that's driving it so big. So the range is great. The problem with it is if you have outliers, which we often have outliers, you get kind of an invalid result from the range, or a misleading. It's misleading, I'll put it that way, because you can get a very large range just from one single outlier. So we have to come up with a better way. The range of this is the number 7, and that is correct, but we have to come up with a better way to measure the width of a data set without letting these outliers destroy the calculation. All right? And for that, we use something called the mean absolute deviation. Let's go back over here for a second and take a look at our previous example. What we really know from this is that if you look at something like this, the mean is at 50, and we have 3 points at 80 and 3 grades up here at 20. What we really know from looking at this is that the mean is 50, but on average, the points in the data set are far away from 50. And over here, the mean is 50, but on average, the points in the data set are close to 50. We want a way to measure that. We want a way to calculate and show mathematically the points when they're close to the data set should have a smaller number, and when the points are far away from the data set, we should get a larger number. So what we really want to measure is how far away the data points are from the mean. I'm going to say that again. We want to measure and calculate how far away the points are from the mean, because everything is in relation to the mean. Here's the mean. How far are my points on average away from the mean? One more time I'm going to say it because it's the critical thing in this lesson. We know the mean. I want to calculate on average how far are my points, either plus or minus, from the mean. It's all relative to the mean. So we find the mean absolute deviation. Deviation means how far away it is, and it's related to the mean. So it's the mean absolute deviation. So we know that this point at 80 is far away from 50 because, and how far away is it? It is 30 points higher. Why? Because 80 minus 50 is 30. And I have another point that's also at the same place. So 80 minus 50 is 30. And I have another point, 80 minus 50 is 30. So all of these points are 30 units away from the mean, right? Now these down here are also 30 units away from the mean, but they're on the negative side. So really you could say that they're a negative distance from here, but it doesn't matter negative or positive. They're still 30 units away, and this is 30 units away. So we know that all 6 of those points over there are 30 units away from the mean. How do we know that? By subtraction, because we subtract 80 minus 50, and we subtract 50 minus 20, or 20 minus 50, however you want to do it, and you get 30, and you get 30. So we have deviations, which are 30 units away. Now, how do we figure out on average how our data looks on either side of the mean? We just take all those deviations and we average them. We average them. So if we have a 30 deviation and 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 a 30 deviation, if we average them all, you know, when you average all the same numbers, you just get the same number. So the average of those deviations is 30. So the mean average deviation is 30. It's just telling you on average how far away are the points from the mean. And the answer that we would get would be 30, which is exactly what you see from the picture. Now what about here? These points are at 51 and these points are at 49. The distance between these points and the mean is just 1. And the distance between these points and the mean is also 1. So the deviations from here is 1 and negative 1, or 1 and 1. And so when you average all those deviations, because these are special cases where the points are all symmetrical, right? But in general, they'll be all over the place. Then you average those deviations, and the mean average deviation here would be 1. That just tells you that on average, the points are 1 unit away from the mean. On average, the points are 30 units away from the mean. So step number 1, we have to calculate the mean of a data set. Step number 2, from subtraction, we take all of the points minus the mean to figure out what the deviation is. And then either plus or minus, you throw away the signs because we don't care if it's above or below. We just want to know how far away it is. And then all those deviations, we just average them. And that tells us the mean of the average, mean average deviation. Average deviations away from the mean. All right, so let's apply this to something a little more interesting than our basic problem here. Here we have these numbers. The very first step is we have to find the mean. So the mean is, here we have 2, or I guess I'll do it like this. 2 plus 3 plus 4 plus 4 plus 6 plus 7 plus 9. So 2 plus 3 plus 4 plus 4 plus 6 plus 7 plus 9. What do you get? You get 35. And then when we take 35 and we divide by 7, we get 5. So what we figure out from this guy, I'll change colors here, the mean is equal to 5. Right? Mean is equal to 5. So on our drawing here, I'm going to put a big blue dot on the number 5, and I'm going to put the word mean down here. Now notice that just like always, we have a mean. There is no data point at number 5, but this is the middle of the data set, and some points are above the mean and some points are below the mean. Now what do we want to do next? To figure out the spread of each of these points about the mean, we want to figure out how far away is this point from 5. Well, it's only 1 unit away. How far away is this point from 5? It's only 2 units away. How far away is this point from 5? It's only 9 units away. So what we do, and the same thing we want to do with these points here, we want to figure out how far each of them are away. So we have to figure out what we call the absolute deviations. What we want to do, and don't let this scare you, but essentially we have these points, 2, 3, 4, 4, and all these other ones, and we want to subtract from the mean, right? So what we get is we take each of these points and we subtract it from the mean. So actually let's go from the top side, from 9. 9 minus the mean is 5. 9 minus 5, that's how far away this point is from 5. 9 minus 5. Now notice we're putting it in an absolute value. This is where the absolute comes from. But 9 minus 5 is just 4, and the absolute value of 4 is just 4. Now the reason we're putting the absolute value is because when the points are on the other side, you'll get negative values. You'll see that in a second, but for now, just continue. Next, we have the next point, 7. Again, minus the mean. 7 minus 5 is 2, and so the mean absolute the absolute deviation there is 2. So we get 4 and a 2. All right, the next point that we get is 6. So we have 6 minus 5, which is a 1, and the absolute value of 1 is 1, right? And then next, we have 4. So we have an absolute value. We have a 4 minus 5, because the mean is 5. Now here's where we get a little interesting. 4 minus 5, what is that? That's negative 1. 4 minus 5 is negative 1, right? 4 minus 5 is negative 1, but when we take the absolute value, it just gets a positive 1. So what have we said here? The point number 4 is what we're talking about. 4 minus 5 is negative 1. We take the absolute value and get a positive 1. All it's telling me is that this point number 4 here is 1 unit away from the mean. We don't care about negative signs. We just want to see how far away the points are, either plus on the top side of the mean or on the bottom side of the mean. We don't care if it's negative or positive. We just want to know how far away it is. So we put absolute values around it to get rid of any negative signs. We just want to figure out how far away the points are on either side of the mean. So 4 minus 5 is negative 1, but when you take the absolute value, you get a positive 1. We have another 4. So again, we're going to get exactly the same thing. We're going to get a positive 1. Now we have a 3. What is 3 minus 5? Well, that's negative 2. But when you take the absolute value, you get a positive 2. Now, when you go up here, what is this saying? It just means this is 2 units away from the mean. It's on the low side. Technically, it's negative 2 distance units lower, but we don't care about the negative. We just strip it away and say it's 2 units away. And then the final point we have is the positive 2 minus the mean of 5. This is negative 3. Absolute value gives you that positive 3. So let me double check myself. I have 4, 2, 1, and then another 1, and then another 1, and then a 2, and then a 3, right? So these are called the absolute deviations. Fancy word, all it means is we take all the data points, figure out how far away they are from the mean. Now, to get an aggregate idea of how far the whole data set is about the mean, we just average the deviations. Some of these deviations are big, like 4 units away, 2 units away. Well, I guess that's not so big. 4 units away, 3 units away. But some of them are small, 1 unit away, 1 unit away. How do you roll it up into one number that's telling you how big the whole data set is? Well, you take those deviations and you average them. So that's why it's called the mean of the average deviations. So what you do is you just take the mean of these things. You say 4 plus 2 plus 1. 4 plus 2 plus 1, then plus 1, and then plus another 1, and then plus a 2, and then plus a 3. So we have 4, then 2, then 1, 1, 1, then 2, then 3. When you add those guys up, all of them together, you're going to get 14. And then 14 divided by how many points did I have? 1, 2, 3, 4, 5, 6, 7. 14 divided by 7 is equal to 2. So the mean average deviation is equal to 2. Right? Now, what we have figured out is that we have a mean right here, right? And what we have figured out is a lot of things. There's a lot of numbers on the board. So let's go over it real quick and then we're going to look at a picture. We've calculated the range. The range is one way of measuring how wide the data set is, and it's just simply the largest value minus the smallest value, and the range is 7. Then we find the mean, and then we figure out how far every single point is away from the mean, ignoring any signs. And we take all these numbers and we just average them together, and we figure out that on average, the points are 2 units away from the mean, right? So the actual range comes out to be 7, because that's the extreme values plus and minus the extreme endpoints of the whole thing. But when you actually aggregate how many points and where they exactly live, on average, these points are 2 units plus or minus from the mean. The mean average deviation is on average 2 units away. And don't forget, we threw the signs away, the negative sign, so it means 2 units away below and above. Now, to show you what that looks like, we have a pretty picture right here. This is the exact same picture as what we have here. All the same data points are here, and the mean is equal to 5. So we'll put the mean equal to 5 right here. And we have a big green curly brace showing you that the range is calculated to be 7, which is 9 minus 2. And then here is the mean, and the mean average deviation is equal to 2. That means that on average, these points live 2 units on the plus side of the mean and 2 units on the minus side of the mean. That's what the mean average deviation is. Because notice some of them were, like 9 minus 5 was a positive 4. 7 minus 5 was a positive 2. But some of these points were 3 minus 5, which was a negative 2. And so some of them are negative and some of them are positive. We just took the signs away. So when we find out what the mean average deviation is, we have to remember that that was an average ignoring the signs. So it means that on average, the points will be this far away on the plus side and this far away on the minus side. So that means that most of your data, quote, most of your data, will be between the number 3 and the number 7, which is 2 units above 5 and 2 units below 5. So if I go in and I tell you the mean of a data set, in this case, the number of wins the baseball team had was 5. That tells you something, but it doesn't tell you the whole story. What you really want to know is what is the mean and what is the mean absolute deviation. In this case, if I tell you the mean number of wins is 5 and the mean absolute deviation is 2, then you know in your mind that not only is the mean is 5, but it also tells you that the data is mostly clustered in a range between 3 and 7, which is 2 units plus and minus the mean. And this goes back to what we said in the very beginning, that you can have the same exact average, but 2 completely different data sets. So if I don't tell you anything about the data sets and how spread they are, then you don't get the full picture because you have the same mean in both cases. In this case, the mean absolute deviation would work out to be 30, and the mean absolute deviation here would work out to be 1. That would be, in this case, the points on average would be plus or minus 1 point around the mean, and here the points would be on average 30 points away plus or minus the mean. The same thing we get when we look at something like this. We have the mean, we know the range, that's useful information, but it also includes the outlier, so we're not sure we use that all the time. But the mean absolute deviation tells you that most of your data lies in this range, plus or minus 2 about the mean, and you do see that most of the data does fit there. Now, I have 2 more problems. It is going to be a lot of calculations, but they're going to get faster, so let me take this down and we'll solve the next 2 so you can understand how to calculate these quantities right now. All right, let's take a look at problem number 2. We have the ages of students that are in a dance class. So we have one student that is 15 years old, goes over there, another student that's 12, another student that's 15, a third student that's 15, and then we have a 14-year-old right here, and then a 13-year-old right here. Let me just double check, and that does look correct there. So the first thing, you can do this in any order you want, but before we do anything else, let's just find the mean of all of these students here, the mean age. So that's the mean age, the average age. So what you do is you add these up. You have one 12-year-old, one 13-year-old, one 14-year-old, and then you have 15, 15, 15, 15, and then another 15, and then another 15. And when you add all these guys up, 12, 13, 14, 15, 15, 15, you get 84. And when you take 84 and you divide by 6, you will get 14. So the answer that you get is 14 years old, all right? So I guess I'll put mean right here, right? Like this, 14-year-old. So you can go on this data set and you can see this is 14 right here. So I can put a little dot here and I'll represent this by the mean. And as you expect, some students have an age that are above the mean and some have an age that are below the mean. Now that's great that we understand the kind of a middle value of the data set. How do we measure how spread out it is? Well, the easiest way is to find the range. we can see that the largest point that we have is 15. The smallest point that we have is 12. So 15 minus 12. So the range is just equal to 3. Now again, the range is great. It gives you a good idea of how spread the data is. But again, if you have outliers in your data, like what if you have a dance student that was 23 years old? That'd be an outlier. Then the range would seem to be really big, even though it was only 1 point. So we do use the range, but it's often not used because if you have outliers, then it makes the range too big, right? So instead, we want to calculate the mean absolute deviation of these points, and that's going to tell us, on average, how far away these points are about the mean, either plus or minus about the mean. You can see that these points are only 1 unit away on the plus side of the mean, but then you have these points that are, this is 1 unit away, and then you have one that's 2 units away. So the mean absolute deviation is going to take into account, on average, that these are this far away and that these are this far away, and on average, as an average number, how far away are they, plus or minus the mean. So the first thing you have to do is find these absolute deviations. Just take each point in turn, in this case 15, and then we're going to subtract away whatever the mean is. So that tells me how far away that point is. 15 minus 14 is just 1. 15 minus 14 is 1. Take the absolute value, you just get 1. You have another point at 15. You have exactly the same thing, 15 minus 14, and you just get 1. You have a third point, 15 minus 14, and you still get 1. So that takes care of all these. Now you have a 14. So 14 minus the mean, which is also 14, gives you 0, and the absolute value of 0 is 0. All that's telling you is that this point at 14 is 0 distance units away from the mean. There's no difference at all from where it is to where the mean is. Then you have a 13-year-old. 13 minus 14, that actually gives you -1. 13 minus 14, -1, but when you take the absolute value, you get +1. That's telling you that, yes, we know this is 1 unit below. That's why it came out to -1. But we're throwing away the signs, and we just care about that it's 1 distance unit away. 1 distance unit away. Finally, 12 minus 14 is that last one, which is -2, and the absolute value gives you a +2. So you get 1, 1, 1, 0, 1, and 2. These tell you how far away each of the points are from the mean. Now to figure out the mean absolute deviation, all you do is you add these points up, which is 1 plus 1 plus 1, plus 0, 1, and 2. You add them up, and then you divide by, you have 6 points here, or 6 deviations here, right? And so what you get when you add 1, 1, 1, 0, 1, 2, you get 6, and you're dividing by 6. And so the mean absolute deviation is just equal to 1. Mean absolute deviation is 1. Now what that is telling you, since the mean absolute deviation is 1, is it's telling you that on average the points deviate 1 plus or minus 1 unit away from the mean. All right, now let's look at a prettier picture of this. We have exactly the same points here. Everything is all laid out. The mean is here at 14, same place where I put my x, and we see that the range is 3. That's just the extent of the data set from the largest to the smallest value. We found the mean absolute deviation to be 1, but that means that the points on average fall plus up 1 from the mean to 15 and minus 1 about the mean from down 1, which is 13. So that means that quote-unquote most of the data points fall within this range about the mean, plus or minus 1 about the mean, which means from 13 to 15, and you can see that most of the data does fall in that range. So you can see that if your data is very skewed, some points will not be included inside of this range on one side, and sometimes they will or will not be on the other side. You can't predict ahead of time what it's going to look like. It's a mathematical average. You're averaging how far away all the points are on either side, and so when you put that range in place, it just means what value we assign to it. It's not like all the points that are of interest are in this range. It's just a number that we calculate. We want to figure out a way to measure how spread the data is. So how far, plus or minus the mean, does most of the data lie? And when you get farther in statistics, you dive deeper into that, like what percentage of the data is inside of this mean absolute deviation and so on. So don't worry about that now. For now, just think of the mean absolute deviation as telling you how far, plus or minus, the points will be, that most of your points will lie. And so it's just telling you most of the points will lie between 13 and 15. So if I tell you that the age of the students in the dance class, the mean is 14 and the mean absolute deviation is 1, then you will say, well, the middle value of the data set is 14 and most of the boys and girls will have an age between 13 and 15. There could be outliers, but most of them will be in this range. All right. let's take a look at our last problem. We have the amount of money that we're getting paid per hour. So let's mark this up on the chart and see what it looks like. So this person gets $18 per hour. This person gets $12 per hour. This person gets $9 per hour. This person gets $13, and then another person gets $13 an hour, and another person gets $13 an hour. Let me fix my little thing here. And then this person gets $16 an hour, and then another person gets $18 an hour. So let me just double check that this looks right before I go further. And it does look right. Okay. So let's start out by figuring out, if you have a bunch of friends and they have a bunch of different pay rates, you probably want to know what the average value is. What's your average friend making? So let's calculate the mean. The mean is 9. We have 1 point at 9. Then we have plus 12. Then we have 3 of them at 13. 13, 13, 13. Right? Then we have 1 at 16. Then 18, 18. So we add all these up and we have 1, 2, 3, 4, 5, 6, 7, 8, and we're going to divide essentially by 8. So we add them up all first and then we divide by 8, and what we get here is 112. When you add up all these numbers, you divide that by 8, and that gives you 14. So the mean of these guys is 14. All right? Now, let's go over here and mark where the mean is on the chart. So the mean is right here. Let me just double check before I move on. Yeah, mean is right here at 14. So I'll put this guy here. This is the mean. And I probably should have used a different color. I'm sorry about that. In fact, I don't like that, so I'll try to cover it up, make it look a little darker, because I don't want you to confuse it with the data points. This is not a data point. This is just the calculation of the mean. All right, so I tell you, the average age or the mean of all these people in dance class is 14 years old. You're like, great, but it doesn't tell you how spread out the data is. So let's find the range to get an idea for that. That's going to be the oldest person, 18, minus the youngest person, 9. And so the range here is 9. So the range there is 9 years old. And that does, or 9 years between the oldest and the youngest person. That does help you. But again, if you had outliers, if you had a really young dancing prodigy or a really old dancer, it would skew it. So we don't use it all the time. We want to focus mostly on the mean absolute deviation. So let's figure out how far away the biggest value is from the mean. 18 minus 14. That's a difference of 4. And absolute value of 4 is, again, 4. Now we have another person at 18. Don't forget to write it down again or else you're going to forget and you're going to calculate it wrong. So you still get a 4. Now we have a 16-year-old minus the mean of 14. This is a difference of 2 years old. And the absolute value is, again, positive 2. Now we have a 13-year-old, and this is where it starts to turn negative. So we have a 13-year-old minus the mean, which is 14. 13 minus 14 is negative 1. That just means 13 is 1 less or lower than 14. So we take away the negative 1. We only care about how far away it is, and we get a positive 1. All right? And we have another one of these points, 13 minus 14. We also get a 1. And we also have a third point at 13. So 13 minus 14, again, is 1. Then we have somebody at 12 years old. So a 12-year-old minus the mean of 14, that's 2 years younger, which means 12 minus 14 is negative 2. But we take the absolute value and make it positive for positive 2. Finally, we have 9 minus 14, right? And that's going to give you negative 5, but the absolute value is positive 5. So 9-year-old is 5 years younger. That's why it comes out to be negative, but we throw the sign away and make it positive. So let me double check. I have 5, then 2, then 1, 1, 1, then 2, 4, 4. That's right. Now, these are the deviations of all the points and how far away they are from the mean. So to figure out the average of how far away all these points are, we average them. So what we do is we say the MAD is going to be equal to 4, 4, 2, or 4 plus 4, plus 2, plus 1, 1, 1, 1 plus 1 plus 1, plus 2 plus 5. We add them all up. We divide by 1, 2, 3, 4, 5, 6, 7, 8 deviations that we have. And so let me just double check here. We have 5, then 2, then 1, 1, 1, 2, 4, 4. That's right. So when you add all those up, you get 20. And you divide by 8. Now this does not divide evenly, but when you take 20 and you divide by 8, you get 2.5. So you see the mean absolute deviation does not have to be a whole number like before. It can be a decimal. So we have 2.5. So what this means is that the range is telling you how far away your data set is in its entirety, but the mean absolute deviation is telling you that on average, these points lie within plus 2.5 or minus 2.5 on either side of the mean. Now let's take a look and see what that would look like. The range is 9, that's exactly what we calculated. The mean is 14, that's exactly what we calculated. And the mean absolute deviation is 2.5. That means plus 2.5 and minus 2.5. So it goes down to 11.5 and up to 16.5. This tells you that most of your data is going to lie in a range between 11.5 and 16.5. And you can see that most of the data does fall in that range. So in this lesson, we've done a lot. It's been a long lesson. I have to do a lot of talking in the beginning because if I just throw you into the calculation, I mean, who wouldn't be scared by this? I'm not even kidding around. If somebody said, oh yeah, do all this stuff. If I just put this in a book and said, do it, it's like really frightening because it's like you have all these numbers and what do they mean? Why are we doing this? Why is it absolute value? So we have to talk about it. We have to talk about it. That's why I don't want to rush through it. So the range is great, very easy to calculate, super fast, but limited usefulness because we always have outliers in real data set. So the mean absolute deviation is just figuring out, on average, how far away the points are, plus or minus the mean, and you will have points on the outsides of that range. Notice over here, the mean absolute deviation was 2.5, so up to 16.5 and down to 11.5, we had points that were outside of this range. All it's saying is that most of the data should lie inside of that range, which is kind of an indirect way of telling you how spread the data is. But it's more focused on not like the range, the entire spread of the data. It's more focused on how clustered is most of the data about the mean and giving you a measure of that. If you have a very high mean absolute deviation, it means the data is very spread out. If you have a very low mean average deviation, it means all the data is clustered very tightly, or most of it is tightly clustered about the mean. And we try to ignore those outliers in that calculation. That's the way it's set up. So I'd like you to solve this yourself. There's a lot of room for error. I would like you to solve it the way I set it up. The way I'm doing it is really the way I want you to write it down. It'll take you a few times. Practice it. When you feel like you understand, follow me on to part 2. We have 3 more of these guys to give you more practice with the range and the mean absolute deviation of a data set. Learn anything at mathandscience.com.